Assalamualaikum. My name is Muhammad Hazwan bin Muhammad Isharuddin, matrix number 105226. Today, I will be presenting my data mining assignment for the course KMK 2533, Fundamentals of Data Mining, under our beloved lecturer Dr. Abdul Razak. In this assignment, I took on the role of a data analysis. I was given a real-world dataset, and my task was to clean, transform, and visualize the data using Power BI, then create an interactive dashboard. Life expectancy is one of the most important indicators of a country's overall health and development. I wanted to understand, where do people live the longest? How has the life expectancy changed over time? And how do economic factors like GDP and education affect health outcomes? By building this dashboard, I aim to help policymakers and health organizations see the pattern clearly and make better decisions. The dataset I chose is the Life Expectancy (WHO) dataset from Kaggle. It contains health, economic, and social indicators for over 190 countries from the year 2000 to 2015. I will show you the data cleaning steps I perform in Power Query. I will go through each problem I found and the exact fix I applied. The first one is country names like Turkey, Congo Republic, and Iran Islamic Republic were not recognized by Power's map visual. To fix this, I use replace value in Power Query. I rename all the wrongly named countries to their standard map names. For example, Turkey becomes Turkey and Congo Republic become Republic of Congo. Without these steps, the map would have blank spots or incorrect location. Now, moving on to the second one, the dataset had two binary columns showing economy status developed and economy status developing. Having both is redundant and confusing for dashboard users. I created a new conditional column called economy status. The logic was, if economy status is developed equals 1, then develop. Otherwise, developing. And then, to make the data model more cleaner, I remove both of the economic status developed and economic status developing column to only show the new conditional added column. The third one is, I noticed many countries had alcohol consumption 0. For example, Saudi Arabia, Kuwait, and Yemen. But after checking, these are legitimate values because those countries legally prohibit alcohol. I kept all zeros because deleting them would remove real data. I documented this as findings in my report. Let me explain every visual available on my dashboard from top to bottom. At the very top, I have 4 KPI cards, which is average life expectancy, average infant death, average GDP per capita, and average of schooling. This will give my viewers an immediate summary of the data. Moving on to the left side are my slicers. First, I have a year slicers, so users can filter by specific years, and region slicer to filter by component like Africa, Europe, or Asia. On the middle section, there's a map showing life expectancy by country. Darker color means lower life expectancy, while lighter colors mean higher life expectancy. This helps quickly spot geographic patterns. On the right hand side, next to the map, a tree map shows infant death by region. The larger the box, the more infant death in that region. And Africa has the largest box. And now to my bottom left are my scatter plot. A scatter plot of GDP per capita versus life expectancy. The trend line shows a positive correlation. Higher GDP tends to have higher life expectancy. And in the left hand side, a line chart of global average life expectancy from year 2000 to 2015. I used the analytics pen to add 10-year forecast, predicting life expectancy up to 2025. The forecast line continues, continues the upward trend. On the bottom right corner, there's two bar charts. This is the top 10 highest life expectancy, and this is bottom top 10 lowest life expectancies countries. And lastly, this is my average infant death by year, showing from year 2000 to 2015. The line is steadily decreasing, which is a positive trend. Now, let me demonstrate the interactive features of this dashboard. I will click on a few slicers and filters to show how the visual responds. First, I will change the year slicer from year 2000 until year 2005. Observe the map, the bar charts, and the KPI cards. They all update instantly to show the data for that year. The top 10 and bottom 10 countries change as well. Next, I will use the region slicer and select only Africa. Now the map highlights only African countries. The scatter plot now only shows point for Africa. The tree map updates to show just Africa's infant death. The KPI cards now show average for Africa only. And you can see life expectancy dropped significantly. Finally, I will clear the region slicer and go back to global view by clicking the eraser icon. All visuals will return to the full dataset. This shows that the dashboard is fully interactive and allows users to explore the data themselves. To conclude, this dashboard is not just about numbers. It is about turning raw data into something useful and clear. What's important here is that anyone, from a student to a policymaker, can open this dashboard, click around, and immediately understand the state of global health without needing technical skills. The cleaning steps I showed ensure the data is trustworthy. The interactive visual lets you ask your own question. The forecasts and trends give you a glimpse of the future. Building this dashboard taught me that good analysis is 80% cleaning and 20% visuals. Without without proper preparation, no chart or KPI will be reliable. So, in short, this dashboard succeeds because it is clean, interactive, and tells a visual story. And that's the whole point of data mining. Thank you for watching. Goodbye.